Thank you. When I realized I would be the last person, I thought, well, that's pretty bad. But then I thought maybe it's not so bad. I could say the most nasty and provocative things and just run away afterwards. But actually, I will not. So consider the following scenario that at some point last year in summer, David goes to Cervinda and says, I want to have a workshop where people from constructing houses, overheating, microbial guts, energy grids, farms, coral reefs, whatever, come together on one day and talk to each other. Do you have any idea how to do this? Oh, make them all talk about resilience. And that's what intrigues me most about this concept, that everybody really likes to talk about resilience. And that's probably the most important asset of this concept. It's what people call a boundary concept. It even goes beyond science now. It's a term which is very much used by politicians and policymakers and stakeholders. So that's really the main advantage, but at the same time also the main disadvantage, because everybody means still different things for resilience. So, and I'm trying a little bit to work on this field, keep the advantages, but improve a little bit the communication and make it easier to use. So when you go back to the dictionary definitions of resilience, the first definitions you get in Google are definitions from psychology. And actually, in science, resilience was an important concept already 30, 40 years ago in psychology. When you go to an airport bookstore, you see from the distance a book titled Resilience. It's about psychology. It's not about ecology. It's also a little bit about material sciences. But anyway, this link to psychology makes resilience very appealing to us because we can relate to it to ourselves. We can feel like an ecosystem which is stressed, because we all know if there's one single stressor, we might be able to cope with it. Let's say we have a cold, we can still go to work. There's another stressor, which is, for example, the boss coming in and stressing around. That's fine again. But then again, there's a drilling machine on the next floor starting to do some noise. That might be too much. And we say, I go home now. That's it. And this basic idea that organisms must have the ability to buffer and cope with stress and change to some degree, otherwise they would not exist. This is very directly translatable to our own performance. And these mechanisms, as we all know, have a certain capacity, and one stressor is reducing this capacity, and multiple stressors might then lead to a collapse. So if these thresholds are exceeded, the functioning of the organism or of the system might get lost. So this is good, and this probably is one of the main reasons why this term is so attractive and why everybody likes it. But it also means that we kind of put ecosystems and organisms at the same level, or what you might call the organismic notions of ecosystems, which is not really appropriate. A mouse, a tree, a human being are self-defined, no matter whether we define it or not, it's there. But in an ecosystem, there are a myriad different definitions depending on our point of view, on our interest and our purpose. And I will come back to that later. But as a reminder, very often people ask me, so what is resilience? And this is probably the wrong questions. Physicists have been very, very successful by avoiding these kind of questions. They're not answering what is matter, what is energy. Physicists have no idea what that is. They use this term to do things, right? So the real question should be what exactly, how do we want to use this term, and what kinds of problems are we trying to solve with this term? Yeah, so I have no idea what resilience is, but the key question is for what purposes could we use it? And as a reminder, we talk about complex systems, including adaptive agents, self-organized, self-familiar over time. It could be economies, it could be communities, it could be stakeholders dealing with urban development. We always have these adaptive agents, and they interact in various complex ways. And as a reminder, resilience has been around a long time already in ecological literature. It was one of the myriads of stability concepts in ecology, but it has become, over the last 20 years, the dominant one. And in my PhD project about 20 years ago, a task was to review the existing stability concepts. And my advisor, Professor Wissel, thought, well, we are physicists, we will just write down 2 or 3 equations, and we will solve the problem forever. And after reading several tens of or whatever papers, I told them, this is not exactly how it is going to work. And it took me 3 years to convince him that my way was the right way. So I felt at some point like a butterfly collector. The most crazy definition I could find, I got really excited. So for this article, we compiled 163 definitions, but there must be many, many more. And so the key question was, how many different, really different stability properties are behind all these definitions? Do we have so many different properties? Do we need so many terms? Or what's the point here? And it turned out that actually there are only 3. And you have heard them already today. It's resistance, so staying essentially unchanged despite the presence of potentially changing agents, disturbances. Recovery, returning to the reference state or dynamics after temporary disturbance. And persistence through time of an ecological system, most easily defined for a population. There are 3 more concepts which are related to these. Constancy is an inverse of resistance, and domain of attractions and elasticity are aspects of recovery. But let's say we have these 3 different properties. To explain them again, resistance, changes in the state variables are buffered, so they do not change as much as we could assume based on the fluctuations of the drivers. The classical metaphor or model system is a chemical buffer, right? The pH value does not change, although we put some drops of acid into the fluid. Recovery, yeah, there has been change because there was little resistance, but the system returns to the original dynamics. And persistence, I can identify the system according to some criteria in the course of time. For populations, it's simple. I just count individuals, and if they're still there, they're persisting. For communities, it's already getting more difficult because is it the total biomass? Is it the real identity of the species? Is it the number of species? Is it the Shannon diversity index? Is it the evenness? So there are many different metrics which we could use to really say this is the same community. I can identify it as the same unit. Now, what Holling did in this definition, this paper from '76, which has since then has intrigued people, including myself, he says resilience determines the persistence of relationship of the ability of these systems to absorb change and still persist. And what he does with this definition, he combines these 3 elements: resistance, recovery, and persistence into one single concept, resilience. You don't see in this definition recovery so much, but if you read a little bit more on that paper, you also see that recovery was included in Holling's definition. So that's kind of a very genius stroke, right? So put everything together in one concept. The problem is that this mixes 2 different kinds of stability concepts. And I call them analytic versus synthetic stability concepts. Synthetic is holistic. It applies to the entire system. So the population is persisting. Whereas analytic, recovery, resistance has to apply to specific state variables, right? So it's a reductionist approach. I talk about biomass, I talk about abundance, I talk about diversity indices. So we have called this the ecological situation. So in principle, you have to specify, is it resistant to what kind of disturbance, at what spatial and temporal scales, and what specific variables do I consider? This of what to what, we have heard this already several times today. So analytic is something which ecologists are increasingly using this interpretation for the last 5 years. I should say ecologists who are not working in the field of social ecology were kind of reluctant adopting Holling's idea. They found it probably too vague and too unclear. But for the last 5 years, there's a number of reviews and special issues appearing. This is the best review on the market by Tom Oliver and others in Trends in Ecological Evolution last year. And they have this figure here over time and a certain variable, whatever it is. And then you have different trajectories. You have age, which is full resistance. There is some change in the environment, some linear change. You have this curve number I. It's limited resistance. So after some time, you see a change, but it recovers. Then you have the curve number J. There is some limited resistance, so it doesn't change immediately, but after some time, this capacity obviously is exceeded. But in this case, there's no recovery. And then you have the combination of no resistance and no recovery. And this is the reductionist interpretation of resilience, which is getting more and more popular in ecology. On the other hand, you have the synthetic notions, and I avoided deliberately the bowl and ball figure here because I knew by this time we would have seen it already at least 8 or 9 times. But it's the same message, right? You have conditions on the x-axis, sometimes also called drivers. It could be the phosphorus input in the shallow lake. And you might have a linear response of the ecosystem state, whatever that is. For lakes, it's phosphorus. It's a level of oligotrophy. So it might go down, or there might be a threshold, or there might be some hysteresis. So this is the thinking of regime shifts and nonlinear changes. And as I said, the challenges are we don't know exactly what kind of variables we should use. Can we find the one single variable to characterize a community or a savanna or a tropical forest? Or do we need 10, 20, 30 different state variables? Can we generalize for one type of disturbance? And actually we can't. The same here, ecosystem state. I mean, for a few cases we know what to put there, but in general we don't know what to put there. Conditions. If we know what drivers are really relevant, we are in a good situation, but often we don't know, and then we might do what Albert did. We might go for 2, 3, 4 different potentially important drivers, and that's then the issue of the field of multiple stressors. And also here, for the analytic situation, this is nice for one type of disturbance, but there might be totally different types of disturbances and changes. So we're kind of caught in a dilemma, which I mentioned at the beginning. We have this synthetic concept, which is related to persistence, and exploring and speaking about resilience will lead us to comprehensive understanding of ecologies. So it's kind of the promise of this term where you go there. Analytic resistance recovery, we can only achieve myriads or more or less unrelated stability assessments. So that's very frustrating. Nobody wants to go there. So what's the solution? And I can't say, in an ideal world, of course, we would just say, well, let's define the system and then talk about the persistence of the system. But nobody wants to hear this, because if you ask people, how do you define your ecosystem? They all close their ears and no. Because it is very difficult, and it depends on our question and purpose. Yeah, if we would know how to define an ecosystem in general, life would be much easier. Analytic, yeah, we should explore recovery and resistance for a wide range of ecological situations. But this is just infeasible, as we all know. So we tried a solution, and we don't have the full answer, but therefore the towards in the title, and we have the term resiliency of ecosystem services. So here we go from resilience to resiliencing, which I'll explain on the next slide. We go from ecosystem to ecosystem services, and we take into account that we have different time horizons and different decision contexts. This is in preparation. So the verbing, the property from resilience to actions, forces us to focus on resilience mechanisms. Instead of asking ourselves, what is resilience, we're asking ourselves, what mechanisms are responsible that we have self-identity of these systems in time, that they're functioning in a similar way over time despite disturbances. So this might lead us to asking better questions. The focus on services acknowledges the normative aspect of dealing with resilience. So the definition is resiliency means restoring, maintaining, or developing of both ecological and socio-ecological resilience mechanisms at all relevant levels of organization and spatial and temporal scales. So building resilience, or this has of course been discussed in other articles as well. Here's just a few examples. Some of them have been mentioned already, Biggs and Chapin and Oliver and Spears. So of course people have thought a lot about it, but I think by going to the term resiliency, really to the action, we immediately ask the relevant question, because here at all relevant scales, this is obviously too general and too vague to be really useful. And so we found out very quickly that you should distinguish 3 different time horizons and decision contexts. And I have heard references to these in several talks today. Short-term solutions, proactive planning, and this kind of stuff. So it is implicit in the literature, and we try to make it more explicit. On the left-hand side, you have the situation that there's some urgency, some emergency, an oil spill, outbreak of a wildlife disease, a flood of a river, and so there's very high acceptance that something needs to be done, no matter what. So stakeholder awareness and acceptance is really high. Uncertainty is low because the bad situation is there, so we do something. And as in the construction case, which we heard this morning about after tsunamis or after some wars, these short-term solutions are at stake. At the intermediate time scale of several decades, the decision context is there is some knowledge of the threat and of the change. An example would be the decline of pollinators, so people know about it and people care about it. The same about the loss of biodiversity. That's the scale of EU agri-environmental schemes or the CAP reform, so people try to do something about it. So stakeholder awareness is existing, acceptance is moderate. The level of uncertainty is relatively high. We don't know exactly what to do, but we have some idea of what is at stake. And on the long time horizon, I mean, I've also heard some cases here, people referring to it. The decision context is total uncertainty. We don't know what kind of stresses to expect in 50 years or 100 years. But we still want to have food, we still want to have clean air and water. And so there's no stakeholder awareness of any measures which would aim at the long time horizon. And so instead of just saying resiliency, we would say we have reactive, adjustive, and provident resiliency. And when we developed this scheme, we didn't know about this adapt. What was it? Somebody said it. Ian left already. It was adapt, transform, or what was in the middle? No, react, adapt, transform. So there's a similar scheme already in the literature. Again, reactive actions clear, adjunctive actions unclear, but some awareness. Provident means actions unclear, no knowledge, no stakeholder awareness, and even the uncertainty is unknown. And so the emphasis is changing. Decision context from urgency to very low urgency, for high acceptance to very low acceptance, from very low uncertainty to high uncertainty, and also the focus is going from recovery. Yeah, we want to restore some initial state after disturbance to resistance. And you can discuss all these things in detail. The details don't matter actually so much, but it's really the difference between different time horizons. So the agenda in our work on this article is still that we want to compile examples of log-ins of resilience, mechanisms due to actions in certain contexts and time frames. So an example is there is a flood of a river and people call for some action. You just make the dikes a little bit higher, so this is a short-term action. But that might actually not help in the long term because due to climate change, we might have changes in rainfall regimes which actually don't help. So we should go for some other solutions. Of course, compile resilience mechanisms and relate them to the 3 types of resiliency. There are compilations, but they are all mechanisms which work under some circumstances and do not work under other circumstances. So they're more so far heuristics instead of something which can be really used as a toolbox. And that's the main purpose of this idea of resiliency. We want to install these 2 memes or ideas in the heads of the people. There is no one-size-fits-all resilience whatsoever. Right? So that's if you forget everything of what I said, that's fine. That's the last talk on this day, but that's the one thing. And we need to focus on the mechanisms of resistance and recovery and how they generate persistence. So take home. Holling's resilience combines 3 concepts. There are analytic concepts, which are reductionistic. You have to focus on specific situations, scales, and that's not very helpful in the long run. Synthetic concepts are holistic, but we are lacking typically the entire system definition. And the possible way out of this dilemma is focusing on resiliency. If you do not like this term, none of my co-authors like this term. It took them about 1 year, and after some time they said, stop it, we like it. And it takes a while to get used to it, I can promise. And there are 3 different time horizons and decision contexts for resiliency: reactive, adjunctive, and provident. And there's no one-size-fits-all resilience or resiliency. Thank you very much.